Hello everyone and welcome back to this video on the first derivative of square root of x using first principles method. Given f of x is equal to square root of x, therefore f of x plus h is equal to square root of x plus h. This x has been replaced as x plus h for f of x plus h. Alright, the first principles method FPM says f dash of x is equal to limit h tending to 0 f of x plus h minus f of x divided by h. So we just replace f of x plus h and f of x here. So therefore f dash of x is equal to limit h tending to 0 square root of x plus h minus square root of x divided by h. So how do we proceed from here? The square root of x plus h cannot be splitted as square root of x plus square root of h. And also we cannot apply the limit here since the denominator becomes 0. So we know that the value of the fraction gets larger and larger when the denominator is equal to 0, right? As denominator approaches 0, the value of the fraction gets larger and larger and hence cannot be defined, all right? So therefore, the only possibility here is we just use the conjugate of this numerator. The numerator here is square root of x plus h minus square root of x. The conjugate of this numerator is square root of x plus h plus square root of x. We just multiply the numerator and the denominator so that the value of this fraction does not change. I hope it was clear so far. The reason why we use the conjugate here is this follows the difference of two squares. A plus b times a minus b becomes a square minus b square. Therefore, the individual bases will have a square, and just in case if you have a radical sign, that radical sign would just disappear. Alright, therefore, square root of x plus h plus square root of x times square root of x plus h minus square root of x becomes square root of x plus h the whole square minus square root of x the whole square. Therefore, the radical signs here will just disappear. So therefore, we have f dash of x is equal to limit h tending to 0. X plus h minus x remains on the numerator and the denominator is the same product, which is h times square root of x plus h plus square root of x. Alright. Now f dash of x is equal to limit h tending to 0. I could just cross simplify this. Positive x and negative x becomes 0. Therefore, only h remains on the numerator and we have a complete product on the denominator. Therefore, I could just cross this h here and h here. So finally, we have f dash of x is equal to limit h tending to 0 1 over square root of x plus h plus square root of x. Now we could just apply the limit. Technically this h becomes 0. We just replace h to be 0. So therefore f dash of x is equal to 1 over square root of x here plus square root of x will give us 2 times square root of x. Therefore f dash of x is equal to 1 over 2 times square root of x, which is the first derivative of square root of x. Alright, so given f of x is equal to square root of x, the first derivative of square root of x is 1 over 2 times square root of x, which is represented by f dash of x. I hope this was very clear and you hope you understood. Please keep watching my videos and do subscribe my channel, and I will see you in my next video. Thank you for watching.